Hey, welcome to this Times Techies webinar. I'm Sujit John, and I have with me my colleague Akhil George. The two of us will moderate this discussion that we are having in partnership with the MeitY Nasscom Center of Excellence. In our webinars and our stories on Times Techies, we have discussed a lot about how enterprises are increasingly leveraging emerging technologies for digital transformation. We've discussed a lot about automation and AI that's focused on efficiency and cost cutting, enabling enterprises to reduce the number of people they need for a function. Today, we're going to discuss augmentation, technology solutions that are focused on enhancing human capabilities, including human intelligence, creativity, and decision making. That's a paradigm shift in some ways, focusing not on automation that makes humans obsolete, but on enabling better human machine collaboration. And that is what we will discuss today. How can we make humans better with AI and emerging technologies?
And for that, we have four seasoned professionals. We have Sanjeev Malhotra. He's the CEO of MeitY Nasscom Center of Excellence. We also have Kalavathi GV, Executive Director and Head of Global Development Center at Siemens Healthineers. Welcome, Sanjeev and Kalavathi.
Thank you. Thank you very much.
We also have Uday Prabhu, Vice President of Innovation Management at Bosch Global Software Technologies. Welcome, Uday.
Hey, thanks so much.
And we have GNB Subba, Global Head of Operations Centers for Process Automation at ABB's Global Industry Services Private Limited. Thank you all for joining us. Those who are viewing this can send in questions through the Facebook comment box. Sujit and I will put them to Subba, Kalavathi, Uday, and Sanjeev. Why don't we kick it off? Sanjeev, maybe we can start with you. Can you help us understand how to properly understand this distinction between human augmentation and complete automation? Are we just splitting hairs here? Maybe we can start with the basics.
Right. So the word automation has been in existence for a long time. It's a decade-old thing. A lot of companies have been built around it. And it is automation can be in different forms, be it digital, be it non-digital, and it has helped us, so far. Basically, automation is driven around rules that the rules are already drawn, and machines are supposed to be following those rules, and that's broadly what automation is. So it kind of reduces the chances of error and chances of, or it doesn't require human intervention at every point wherever the processes are predefined. But now we are coming to a point, the digital technologies have come out with so many newer manifestations, be it in artificial intelligence, machine learning, or AR, VR. It is changing the way we all are performing in different domains. It is enhancing the way we do our daily tasks, we as in professionals in different domains. If I talk about how a surgeon is going to be performing surgery, where he gets a view of internal organs from different directions, things which are not visible to the naked eye. He uses a screen in front to visualize what is there behind the visible part. That helps him perform in surgery in much more precise way. Similarly, if I pick up pathology or X-rays, or where a pathologist is trying to write a report, looking in the microscope for the biopsies, he's getting indications from AI. These are the areas to be looking at. Sometime a human may miss out on things, given the vastness of details or minuteness of the details, or the fatigue on the person. Could be any reason. That's where some of these human capabilities get augmented by the fact that AI is telling you these are the areas to focus on. Here I suspect something, then humans can go and validate and make their job faster and gets it more accuracy into their job. So I see that happening in every sphere. If I take example of fintech, where we see people are doing loan processing, and their loan processing is getting faster because AI has already done some document checks, something that used to take hours or days. Now much happens in much faster way, and less round trips for people who are actually trying to get loan. So these are some of the examples on top of my head. But the point I'm trying to make here is these are the places where whatever it adds accuracy, it saves time, basically augments whatever professionals are doing, it makes them do much better and faster. That's the broad distinction I'm trying to put. And this is not totally governed by rules. Even machine is learning and getting smarter along with us. So this is broadly what it is.
And you're seeing startups and enterprises working together to create these kinds of solutions. You work with what you said, some 500 startups. They're already doing some of this work.
Right. The startup ecosystem in India has matured pretty significantly over the last few years, and the technology has been moving at such a fast pace. So role of these startups is becoming far more important what it was earlier. And I see these startups, basically in every domain, who are trying newer solutions, and some of that I already talked about. And enterprises are beginning to partner with them and take advantage of it because it helps them get onto the journey much faster. It helps them to, rather than having to do, I invent everything here, I rather partner and move quickly, try fast, fail fast, right? This kind of a the nimbleness that startup brings, I think, is being appreciated by the enterprises, and they're beginning to partner more with them.
Oh, very good. And we're beginning to see impact. I mean, there are enterprises which are adopting it.
Absolutely.
Yeah.
Absolutely. So it is not actually, I will add to it, it is not just the enterprises which are benefiting from it. Even governments are beginning to use it also.
Oh, very
So
good.
we work with a lot of state governments which are working in areas, be it detecting illegal encroachment or theft detection in electricity. So we are beginning to solve those type of use cases. And I'll give some interesting examples as we go along. How state governments are also using these startups for adoption of the solutions that they're developing, and bringing in new thinking and bringing new approach within the government. So a lot of state governments are taking a lead.
We'll come back to that later.
Yeah.
Uday, Kala, Rao, I mean, same thing. I mean, give us an idea, the kind of work that each of you is probably doing in your own companies along these lines.
Yeah. So adding on to what Sanjeev said, I think the world is transforming from automation to autonomous system. Just to give a baseline, half of the world population does not have basic healthcare services. So there is a need for us to increase the access. Now, post-COVID, one thing which became prevalent is the digital, right? Digital and the deep tech technologies, which can help you increase this reach. So if you take, what does it mean for healthcare? The transition from automation to autonomous system, it represents a paradigm shift. Whatever Sanjeev said, I'm rephrasing that. From a rule-based, human-supervised tools to AI-driven systems, which is capable of making decisions using the data, right? So this is where it is not about human versus machine. It is about human being enabled much more with the intelligence that the machine brings. So for instance, if you look at automation in the healthcare, traditionally it was focused on workflow efficiencies, automating patient data entry, or scheduling, image processing, etc. But on the other hand, if you look at autonomous, where it is augmenting the human capability, right? Here is where deep tech is bringing in huge transformation. For instance, there are AI-enabled imaging tools which support the radiologist in identifying anomalies much quickly, right? Healthcare is all about, you have to move towards prevention, or at least predict as soon as the symptoms or even before the symptoms occur. So this is where The tools help the radiologist or the user to identify anomalies quickly and see how you can enable faster and more accurate diagnosis, right? And also not only AI, if you look at robotics. So many of us have heard about minimally invasive surgeries or even the knee surgeries. So this is where robotics plays a very, very important part because it is going to support the precise surgery that can be done. That will also help in faster recovery for the patients. So moving on, next example is the digital twin. Okay, this is what the world is moving towards. How can you build a twin, either of a patient or a hospital or whatsoever, because you can actually, using all the data, personalize it, simulate it, and then see how the disease is progressing or how the treatment is progressing. So these are some of the angles that we are looking at in healthcare. And this is going to help reduce the burnout. Because as I said, if you look at the number of patients to the number of physicians or nurses who are present, there is a vast difference, 1 is to 1,200, right? So whereas if you look at WHO, they say 44 people per 10,000, I would say, patients. So we are far away from whatever is needed. So this is where the autonomous systems or the progression towards autonomous systems is making it possible for keeping people healthy. So in a sense, while automation streamlines tasks, autonomy promises transformative care through adaptive intelligence, and then it is going to make it much more personalized.
Okay, we'll come back to some of those. I mean, each of those areas is very interesting. Radiology, robotic surgery, you mentioned, digital twins, of course. And but before that, let me get Uday and
Yeah.
Rao.
So
Yeah.
I think no great examples. So at BGSW, since we are the software powerhouse at Bosch, a great enabler to our developer ecosystem is how do we provide them the tools to do their job better. So if I am a software developer and if I am looking at uh, increasing my output or making lesser mistakes or conducting a series of tests faster, what would be my support ecosystem. So providing these AI tools where you get the entire knowledge base of past projects, you get the entire knowledge base of past problems injected, and allowing the user to make decisions on the fly, saying these are the possibilities. This is where no, you potentially went wrong the last time. These were existing no challenges that were that were injected last time. So how do I not make those no same mistakes? How do I provide possibilities? How do I bring in best practices on the fly? Right. So if you take the traditional V cycle that used to exist in the engineering industry, now the V cycle no longer is a V cycle, right?
What's a
So
V
you have
cycle, Uday?
so
I'm not an
so
engineer.
in an engineering context, you have you start with requirements, then you do design, then you do coding, then you do testing, and then you do component testing, system testing and product testing, right? So there's a design cycle, and then you have a testing cycle. That's called V. There's of course there's W in other industries because you do it twice. So now the whole aspect of developing and testing has sort of got crunched because now the whole cycle of testing is moving into automation, right? Creation of test cases is being done using the help of AI. Creation of code is being done with the help of AI. So you have co-pilots, you have testing systems. So you're pretty much flattening the V cycle to a large extent. And developers used to do a code and then you pass it to another person who will test it. Now we are bringing in AI as an intermediary, as an assistant, who is able to sort of provide information and assistance to the engineer on the fly, right? So the whole time has sort of got crunched. So in engineering, we typically have a metric of QCD, right? Quality, cost, and delivery. Delivery being time. right? So now with augmented capabilities, quality is getting improved because you're able to detect issues, your bugs upfront, on the fly. Time is definitely a big thing, right? You're crunching the cycle to a very large extent. And then by virtue of this, the overall cost of development has come down. So if you look at it, 10 years before, a product life cycle used to be around 3 years, right? And now you're talking about product life cycles which are under a year, right? So that's the impact technology is being able to provide. And no, this is on the development side. If you look at it from augmenting workers in manufacturing, or if you look at augmenting workers in aftermarket, say diagnostic, when you're trying to debug a vehicle. So we have augmentation capabilities. For example, you can say what is wrong with a vehicle by looking at the symptoms. You can assist the worker on where exactly to go and find the problem, right? For example, how do I detect where is the wiring harness in a vehicle through augmented reality apps, right? You can point out how the cabling goes, where to actually go and find the problem. Uh, and if you go back 3 years, you had like a 500-page booklet, right? Which you had to go through training, right? Sit in a classroom, understand. And even when you're debugging, you have to say, okay, chapter 10, 20, go to this to understand how to replace a certain, say, valve, right? Today, you take a tab, you point it at the thing, and it'll show you where to do it instantly, right? So all that information is being crunched and provided in real time to these workers. So that amount of knowledge instantly being provided is a great augmentation tool, right? The right information instantly can do wonders.
Absolutely. We'll come back to some more specifics about the automotive industry a little later. Uday, Rao, you want to tell us, you work with a lot of process industries. You mentioned oil and gas, cement, steel. Give us an idea of the kind of work possibilities now.
Yes, Sujit. So I will take all of us away now from the wonderful fields of medical software into manufacturing, and specifically manufacturing related to, let's say, the process industries. And I mentioned this because they are demanding, highly demanding. Number one, reliability needs are very high because once you start a process, it is expected to keep working for months together, if not years together. So no interruptions. So reliability factor is very high. And also the places that we go into for the processes, they're quite remote, difficult, and sometimes even hazardous. Example could be, let us say, an oil rig or a platform in the Arctic zone. It's very cold. You don't have any sort of mankind close to the place of operation, but you're still expected to drill down many kilometers into the ground to get us the oil or the gas that we desire. So how do you do it? And that's how ABB, from the process automation side, started developing automation, which would, as we spoke about it earlier, which would automate many things and sort of make it easier for people not to be involved to a large extent. So that's the background that we come up with. Another excellent example where we have augmentation of human capabilities and machines, but also the involvement of very high standards of safety and productivity is, where they become important, could be a mining industry. Let's take a typical coal or ore industry, mining industry. You're expected to dig down and get into unexplored sort of areas. And when I say unexplored, you really don't know what you're going to come across. It could be a loose sort of soil mass which would come down on you, safety. It could be gases which are harmful. And in many cases, it could be gases that are not visible At the same time, they do not have odor. So people just get into an area without realizing that they're walking into a death trap. Now, how do we, but yet we have to send people there sometimes, or we have to definitely send machines. So we automate such processes. We also bring in the cutting edge technologies as and when they are available. And many times we also explore these cutting edge technologies to adapt them to our needs. For example, I spoke about this gas area, which could kill people if we don't detect the gas in time. And unfortunately, neither they are visible nor they have any odor. So we have sensors now that can detect it quite in advance, and not just detect the presence of these gases, but also suggest certain actions for saving the human lives. So these are the things that we have been involved in. And as I said, it started off with automation, which itself was a very big step as far as our comfort goes. But then we have evolved into use of every cutting edge technology that has come our way. Digital. You take the case of digital, we have excellent features now, which we make use of to analyze situations, to augment the machines, to augment humans. The latest is the other one in between these two was machine learning, where we would actually make the machines much more capable by sort of learning a lot of things themselves. Now you have AI, which would, I think, the initial sort of forays into it suggest that they can be sort of revolutionary. They can make things that we had never imagined earlier. We are experimenting with a lot of them in our processes, starting from, let us say, the entire life cycle, and in certain cases, bidding, engineering, commissioning, servicing. We have experimented with digital as well as AI on all these fronts, with, I would say, very encouraging results. Fantastic. And one of the examples that I can quote, which is fresh in our memory, is still fresh in our memory, I would say, are the COVID times, where we were hit very badly. We were prevented from going into places that we would naturally want to go to. It could be customer sites, the customers wanting to get into their sites, our offices, etc., etc. We were not able to go there. We were actually prevented to go, into those places. But fortunately for us, we had digital working for us in many ways, in very methods, I would say. And while we did initially see a little bit of a hit, what technology made us do is to actually not feel the effect of inaccessibility. We were able to do a lot of things sitting where we were safe from our homes or from our isolated offices, and do almost everything that we would. And that changed the paradigm. And that's how we started talking about remote working, etc., etc. But with AI, that's an excellent example of digital. But with AI, I think it will be much more. It would be adding intelligence in some ways to the machines, as well as augmenting human capabilities to a very large extent. So, as I said, without getting into specifics, because they would take days and days together if we start discussing that, I would say in every sphere of our activity, we have experimented with the AI, and it's giving us excellent results.
Okay, we'll come back to that more later. Akhil?
Maybe we can touch on how some of these companies have actually built all of this, especially what Kalavathi was saying about digital twins. Kalavathi, do you want to give us a little bit flavor of how are you building a digital twin of a human being, for example? Because I'm assuming, what is the sensors? If you take readings, how is it? Please help us understand.
Okay, so thank you for this question. So in order to build that, the first thing is the infrastructure, right? So we have a supercomputing infrastructure, which is in Princeton. It is called Sherlock. It is known worldwide. It is a supercomputer with a capability of 100 petaflops of data. It runs about 1,200 daily deep tech experiments. So we have curated data sets. So see, building a model is good, but the model is as good as the data that you fetch to it. So we have about 1.2 billion annotated medical images, that is used for testing. right? That is used for making the model much more precise. Now moving on to digital twin. So this is where digital twins, we build virtual replica of patient. Normally digital twin of the patient is the vision, but to progress towards that, we start with some of the anatomies, right? So this is where we build the virtual replicas of the patient anatomy, physiology, or even disease progression created by integrating the imaging data, okay, and the clinical data, and then AI data simulation. So basically, this models allows the clinician to simulate everything specific for a patient and respond to different treatment options. For instance, they can run the digital twin to really understand how the disease is progressing, what is the treatment which can be personalized, and once the treatment is given, how the treatment will progress. So that is what is the intent. They are also model of patient health over time. That's what I'm saying, how you can anticipate the complication and how you can adaptively or proactively adjust some of the treatment plans. So this is the direction that we are going. So currently we are working on partial digital twins, okay, for specific organs, especially heart and liver. For instance, let me take the example of the liver. We are working on creating a model that replicates the organ anatomy, right? And including the shape, the vasculature, if there is lesion, okay, when you say cancer treatment, there's a tumor, etc., that's a lesion, as well as physiological processes like blood flow, because these are all very, very important, okay, and hepatic functions. So using all this, like, when you simulate, it'll help the clinicians to evaluate and refine the treatment options, okay? In the same way, when you take the heart, okay, heart beats a certain times per second, right? Now, if a person has diabetes or comorbidities, right? So it'll progress. The progression of the heart disease happens in a certain way. So we have built models like, where you can make the heart beat at a certain rate, which it can simulate per year. Okay, it can simulate the whole heartbeat of a year in 5 minutes and really understand how the disease is progressing or how the treatment is progressing. So this is an example of digital twin, okay? We want to go towards the patient digital twin or the enterprise digital twin, but the start is to do with some of the organs.
That's fascinating. So basically, you're helping automate the work of cardiologists and
Yes.
hepatologists.
Yes, absolutely.
So you have engineers actually working on that right now.
Yeah. So the way we do is, see, AI, when you get into digital AI, everything, it's all about trust, right? And then if you look at medical data, because of the data that we are getting from everywhere, it is progressing in such a way that if you don't have AI models or if you don't have AI helping you, it'll be very difficult. And also, if you look at healthcare, it is very regional. The disease prevalence in India is very different from the disease prevalence in US. So we use all this and then we build the models and then we provide this data, regional data to the models to make it very specific to the regions or to a particular scope of the disease. Okay, so that is how we provide those. And then we make these tools enable the user. It can be physician, it can be radiologist, cardiologist, etc., in order to make the right decisions. And so we are enabling them. And finally, it is the physician or it is the user who is going to make the decision. So this is where the trust factor is still intact, because finally it is a human with the help of these tools who is making the decision.
That's why it's augmentation, right?
Yeah, mind-blowing stuff. Sanjeev, I mean, you mentioned that you're working with getting startups and the enterprises to work together. Give us one good example, the one that you're most proud of, where you helped facilitate a deep tech startup working with industry to enhance human capabilities. Of course, you also mentioned those government use cases that you can talk about that as well.
Right. So as it is coming out pretty evident, right, we are able to do newer things now with the technology becoming more accessible to everyone and newer use cases coming out of it. Some of the latest ones, I'll tell you the ones which are just happened in last month or two. We have been working with on this eye camps, right, which they are putting in Tamil Nadu, and the lot of when the people come for consultations and some of the procedures happen and the prescriptions are given, people have a lot of questions, follow-up questions to ask, right? Now, doctors don't have time to do answer all these things. So I think Shankara Nitralya wanted the solution, which is a perfect example of Gen AI, where we feed in the prescription and some of these questions, are repetitive and answers are already there. And some of that it can understand from the prescription which answer has to be given. And some of it can make out with the knowledge it already has. Patients through their app are getting answers, questions answered even at home. They don't have to meet the doctor for everything, right? So it makes the job so much simpler. Both life of patient is better. They are getting, they can talk in Tamil or whichever language, it can be translated, any language it can be done. And doctors are not inundated with those queries which are repetitive in nature. And even if they're not repetitive, they are still can be solved, and they're already there on the prescription. It can be seen from there and translated in a language which is easy to understand. So look at the efficiency it adds to the system. Look at the convenience everybody is getting, and everybody's feeling good about it. That yes, I don't know what to do. Yeah, I went there. So this is the newest thing that we have done.
Who built it? Can you name the startup or?
Yeah. So there's a startup by the name GV Technologies. One of those guys who are working with the med data. In fact, their model is so good, it beats even OpenAI when it comes to medical, because there are rankings, some organizations do the ranking.
Really?
And the accuracy of the model is better than OpenAI. And in fact, they're number one in the world. So based in Gurgaon in our center. But that's the kind of work that is happening and translating onto the ground. So I'll give you other examples where government has been active in using these technologies. Is detecting illegal encroachment, right, in areas. So earlier, how it used to happen was somebody will do a physical inspection of places, go there and detect that. And then, of course, we started getting satellite images. Still scanning the satellite image of entire state is not an easy task through human thing. And now the newer ways that they're doing is, okay, you look at today's satellite image, compare it with 3 months old and see what is the difference. It will automatically pop up, right? Now, it's so easy for somebody. Now government has that data easily accessible to them. And that's a use case we are currently working on.
Which startup is that one?
That startup name is SatSure, is working with us, Bangalore based.
Heard of it,
And the other one is that we are working on is in the government, they wanted to see where the stray animals are. Not only see where the stray animal, they want to detect the animal also. Now, how do you detect a cow? Not many people know that, right? You can detect a cow through nostrils.
Really?
That's a
Okay.
unique thing. Now, we had a problem where to put a camera. Nostrils are down and then camera is up. So there's some interesting areas we are trying to deal with. So I'm telling you the diversity of these applications, right? And as some of our leaders like Nandan Nilekani and all are saying, right, we have to be use case capital of the world, and that's what we are trying to become. Put thousands of use cases, make it easily accessible for everyone at a ground level, at prices which is not prohibitive. And I see that every passing month I see newer things happening. It's not been a single dull day on this, right?
And you see enterprises wishing Indian enterprises, or is it mostly GCCs who kind of work with these kind of startups to bring it to market?
Oh, absolutely. The live example here is Kala. Their solutions are adopted by Germany. They take solutions from there and, in which they augmented their sales training through AR, VR solutions where they don't have to physically. It started during the COVID time, but now it kind of become a regular practice. You use AR, VR to train your sales force remotely. Plus, they are working on few other use cases which are proprietary to them.
Yeah.
So starting from there, Bosch has been pretty active. They have had programs on many kinds. So yes, it has been very startup enterprises are making this as part of their sort of R&D and forward-looking innovative work to work with the startups, to use their solutions internally, partner with them in some way, or invest in them in some way. Multiple ways of engaging with them, and it is all happening as we speak. And that tribe is becoming bigger. Earlier, people were skeptical, but now the success stories are coming out, and overall, the feeling is yes, that's a good thing to do. You augment your R&D work with what is happening in the ecosystem. And Indian ecosystem is also becoming much better and mature. So that also is making a difference, adding to the confidence of corporate leaders.
So nice to hear that. Akhil?
Yeah, maybe we can hear a little bit about Shivara. You were talking about a lot of examples during COVID, how you managed, right? That, but when it comes to such a physical job, how did you actually do that? Was it through the help of robotics and cameras and sensors? Because your job, it's not just sitting in front of a computer, right? When you're talking about all these manufacturing and industrial settings. Could you help us understand?
So again, a lot of physical activities and physical objects involved here, along with humans and of course the software as well. And in addition now, what helps us is having, let us say, the cloud. And that is so much about digital, in the sense, how do you take advantage of cloud? How do you take advantage of the enormous storage capacity that we have for data today? It's becoming cheaper and cheaper and more accessible. And how do we transmit data? How quickly, how efficiently we can transmit data? So these are the important things that would define how well we can adopt to digital or AI, etc., etc. And to us, to me, and to our organization, what these capabilities, be it on cloud, be it on the data transmission, be it on sensing or storage, how these have played an important role has defined how we could enhance our services to our customers. You spoke about COVID. Yeah, that brings again to my mind another excellent example of what happened in Turkey. I could name even that country. It was COVID times, but it was also, I think, if I recollect right, a time when they had a huge earthquake, and they were then, the country itself was in need of huge amount of building material, including cement, but cement which was entirely different from what they were manufacturing at that point in time. So they needed a, let me put it this way, they needed a change in the grade of the cement. Now, while they were good, they have always been good at their technologies and cement technologies. They probably were not having enough capabilities to change the grade and change the grade of the cement produced very quickly. So they do have a lot of work with us in this center. This is a center which is called ABB Innovation Center, and we do produce a lot of software products along with the which fits in very nicely into the physical world. But we also support them by commissioning these products and providing health services for them. So when they did contact us, we were able to hook up to their control systems sitting in Bangalore. And because we have experts here in automation, in chemical engineering, in mechanical engineering, etc., this team was able to look into their exact problem, change a few things through the software that we had provided them onto the plant. And I think within a couple of days, if not maybe 3 to 4 days, they succeeded in changing the cement grade, and it solved their problem, the customer's problem. But I would dare say that it also sorted out a national problem for them, because they were in dire need of building materials after the earthquake had shaken up a lot of things. So this is another example of how digital and how AI is playing a big role in the physical world as well. Of course, we have robotics, we have AI augmented robotics. We also have a lot of, inspired by what Kalavathi was telling us, and also Sanjeev on diagnosis, etc., etc. I would extend it to diagnosis as applied to machinery. Let us to say a very simple example that would strike us, all of us, is a motor. Now, a motor is a running equipment, and it is again expected to run for years together. It's what you see in your borewell or maybe in your AC system, etc., etc. You don't like it to break down. Now, but it breaks down. Like the humans do, they often break down, and the trick is to anticipate what is the cause for the breakdown well in advance so that you can prevent that. So we have developed something which is called, I won't get into what it is actually called, but then for a layman, it is a motor doctor, which is a set of sensor on a very small, PCB, which can be mounted on on a motor, that keeps sensing a lot of vital information about the motor. It is, information like temperature, speed, noise levels, etc., etc., and it's able to sort of pass on information, diagnostic information to operators as well as engineers well in advance, saying that, look, there is a possibility that your shaft will probably break down in a few weeks' time. Can you do something about it? Then you have the AI part, which would then help the engineer as well as operator decide what's the best solution to this. And they have, with the help of this solution, prevented many breakdowns of the motor. But to me, it is not just about the motor breaking down or preventing the breakdown of the motor. Remember, the motor is a part of a very big machinery or a system of machines which would be working in tandem. So one breakdown of a motor could mean that a whole plant comes down. So it is the prevention of, let us say, the whole plant. So there are many numerous ways in which these new technologies are helping us. And we are always on the lookout for such technologies that would augment our capabilities on automation to help humans, to help, as in these cases, even the machines. And believe me, the machines are tough to deal with. They are predictable, but the problem is they don't talk to us and they don't tell us anything. And the secret is to find out what's in their mind without talking to us. So that's a big task. So we managed to do that, all with the help of digital and AI technology.
These sensors have become so good. I mean, that one, I remember writing, by the way, about that motor sensor some years ago, ABB's motor sensor. But these sensors, you said, can be put in mines and it can even detect what kind of gas and all that. Is it? These sensors can find out a lot of information about the environment.
Yeah, Sujit, I spoke about technology advancement that has helped digital and AI to a large extent. I spoke about storage of data, transmission of data. Another very important aspect is the sensor itself. The sensor technology, the miniaturization of sensors, and the price or the cost of sensor has seen a remarkable progress in the last few decades. So we have, for example, if you take this mobile phone, just imagine how many sensors it carries. Nothing less than 15 to 16 sensors.
Okay.
In this mobile. So we all know that it's no longer a telephone, it's so many other things. So all this is because of the sensors, and they're so small and they're so affordable that I can get maybe 15 or 20 of them in my phone. That's the amount of difference that the sensors have made.
Okay.
So we are talking about sensors that can, let's say, sense the vibration of a motor along with the heat and voltage, current, etc. You spoke about mines, you spoke about blast furnace areas in steel plants. So they can very easily sense certain gases.
Yeah, you mean it can differentiate between one gas and another and all that?
Oh yeah, yes.
Okay.
We have sensors today that are mounted on drones that would be continuously patrolling the pipelines to detect any leakages. And remember, there are many types of gases, so they are able to tell us which exact spot is the leakage and what is the gas that is coming out.
Okay.
And not detecting that on time, of course, is a big loss, but it can be sometimes very catastrophic as well. It can cause a lot of accidents and undesirable things. So you can't have humans, moving around, and
Moving
it's
around.
almost impossible. It's not
Yeah.
just, cost. It's impossible to have humans, moving around detecting it. So the easy way is to have a drone mounted with a lot of sensors, and you can almost do it online.
Okay.
So this is the world of sensing that has changed a lot. So you put a lot of these things together and produce something which would help all of us augment our, our
Okay.
capabilities.
Uday, I guess you also have all of this stuff, no? Oh,
Yeah, I just wanted to pitch in here and talk about. We have two terminologies. One is called as Edge AI, right? So software is the future and will be the main control point in almost all products, going forward. So we have software-led everything, software-led, software development. No, we call it as SDV, software. Then we have software-led products, and off late everything is becoming personalized, differentiated, and context aware, right? So that is where AI is helping products to become more unique to its user, or unique to its application, and look at how to augment it. So I think taking a cue from what Mr. Rao was talking about. So in engineering, we say that if you can see it, smell it, or feel it, then it's already too late, right? Especially in manufacturing. So you don't want to see it, nor smell it, or feel it. So this is where AI comes in handy. That all this information from the sensors, when they are collected, they're able to look at patterns and provide you that information very early, right? Early use cases. Because if you plot a graph of time of detection and cost of repair, right? So as you go later down the path, the cost of repair starts to exponentially increase, right? And so it is in the interest of engineering that you are able to detect it very early, and take preventive actions. So we have, as almost everyone, digital twins, where, of course, Kalavathi is working on the person, and we're working on the machines, where we create a digital twin, which is created, using physics, right? So you take the CAD models, you put in the physics, and the information from the sensors are provided to these models, and you are able to predict how the machines are going to behave. And as the anomalies start to percolate, the models will start, throwing out these flags, which will allow the maintenance guys to, come in ahead of time and fix it, right? So these are what we call as phygital systems, physics and digital coming together to make those digital twins. And of course, there are digital twins for large machinery, and now we have digital twins which are for entire processes, right? We call it as a process twin as well. And there we work with certain startups as well, who provide us those cognitive AI process twins that look at simulating entire processes. Or it could be a plant, it could be maybe an airport, or it could be a port, where things move according to, because everything is interlinked, like it's a multi-variable system. So being able to detect what is happening and then predict how the entire process or the plant is going to get impacted, things downstream, is a powerful, augmentation to a maintenance person's life, right? He's able to take actions before you can smell something burning, so to speak. Right?
Can you give some example? You said product life cycles have been shortened and all that. Is there any specific example that you can provide from your own experience in Bosch? What have you?
Yeah. So if you take software engineering itself, right? We had, I think I mentioned earlier on that we have had 3-year life cycles to build products, right? Almost all
You said it's
industries
less
we
than a
had.
year now.
Yeah, now it's less than a year.
So these are
Why is that?
what kind of products, Uday?
For example, products in the automotive space, right? Or it could be a new feature development for industry or for mobility, right? With this ability to create large iterations in a very small time, you're able to create features on the fly. The new concepts of software-defined vehicles, right? You're talking about adding features on the automobile on the fly, right? Earlier, you used to take in a requirement, go through a large cycle of development, and then in the next vehicle launch, right, you add a feature. Today, you are able to add a feature after you have purchased a vehicle, right? So that's the progress that we have seen with respect to building features through technologies.
Okay. And you said you're working with startups on some of these
So
process areas particularly.
in the manufacturing space, for example, in robotics, now we're looking at software enabled autonomous robots, right? We are working with startups on that space with emerging technologies.
Any startup you can mention?
In the robotic space, there are many. We are working with, for example, Answer Robotics, who have their own AMRs. We're working on the software portion for them. In the cognitive twin space, we started working with companies who are like CloudWorks is one good example. They're doing a lot of good work, and so on. So as a software company, software is at the center of what we do, right? So software-led innovation is what we call it as. And so, as I said, software will be the center of everything going forward, and that will be the space where innovation will thrive, products will thrive, and feature and applications will thrive.
Okay, great. Akhil?
Yeah, Kala, can you help us understand when you're doing all of this work across continents, what is your biggest hurdle when it comes to adopting AI? When you're talking about the healthcare, especially, it's a sensitive subject, right? So,
Yeah.
What's the biggest issue that you face?
Yes. Okay. So I'll talk about both our own people and then for the people whom we are delivering. So the first thing, the technology is moving at the speed of light, right? So how do you ensure you upskill your workforce in order to keep up? And then not everybody have to be specialist in everything. How do you segment? And how do you connect all those things? Because when we are creating something for the users, it is all about user-centric design. So that is something that we are looking at. How do we have the UX, that is the user experience team, who will work along with the users to really understand how things happen in an enterprise, and then how our solutions is going to help them. So starting from there, starting from the customer journey, how do we work backwards? And how do we use the specialists to come in and then say what is better? So overall, and also how do you work with the ecosystem to make things happen? So that is one thing. Second thing is, of course, we deliver some of these things, but how do you get the adoption going faster at the enterprise? But because people are used to doing things in a certain way, right? So how do you go show the practitioners that taking this, the new thing that you're doing is good for the enterprise, right? So that is where understanding the existing workflow and adapting it for easier stickiness rather than disrupting it is very, very important. So that's where you have to balance. When it comes to healthcare, the trust is extremely important. Okay, we talk about this AI, data, and then everything, right? And so many a times, when the initial AI came in, it'll come and then give you the outcome. Explainability was a biggest problem.
We lose.
So I think as we foundational, explainability is becoming much more prevalent, right? So the transparency, the explainability are the key building blocks. And the next thing which comes in is the privacy and the security concerns. especially when you're dealing with the patient data and then with all the hacking going on. So how do you ensure that you have the highest security? So these are all some of the challenges that we are getting. And then finally, the data quality and the biases. Because many a times I'm sure that you're reading about the hallucination, right? So how do you ensure that we get the right data, you train the right model, and have the feedback loop so that you can progressively improve the intelligence of the model? So these are all some of the challenges that we are facing, and we are coming up with mitigation as we are going through. And finally, it is about how do you get the approvals, okay, the FDA approvals, especially when it comes to AI. There are frameworks which are being built, and then using the generative AI for document creation, etc., right? And learning from what is happening, etc. These are all some of the progressions which are happening. And it's not just about all these aspects, but AI is more of a cultural shift. It is the leadership setting the right tone in the organization, setting the right cultural shift in order to take the technology to help, okay, and making us much more human. Okay, so that's where I would stop.
Cultural shift, no, absolutely. Something related, Sanjeev, I wanted to ask you. There's also this question along this. I know we asked you this question earlier, but maybe you could elaborate a little more. Agrima Sharma asking, would enterprises be open to collaborate and work with Indian startups for new innovations? Now, here, let me be a little more specific. Indian enterprises, the large businesses, there's always somewhere this concern that they don't seem to be so interested in working with Indian startups. Is that a problem? I also want to ask you what kind of mindset shifts are needed from both corporates and startups to foster meaningful collaboration that leads to these kinds of innovations. Sanjeev?
Yeah, no, good question. While we have a lot of successes and success stories, there are equal number of skeptics out there, and those skeptics would be of for multiple reasons, right? And the one of them could be, how do we have such kind of level of startups in India, right? Second could be, do we really want to do the startup thing? I mean, a lot of people have this not invented here syndrome also, right? If it is not made here, I mean, that's typically true of engineers, right? I mean, if I'm sitting on the other side, probably I'll think like that also, that, we have capability to do everything here in this organization. Why do I need to go out? And I think some of them are on the other side also. I think so. I think the fear, the fear of the unknown, or fear of or looking at some of the positive side, missing out on those, I think are the reasons. But I would see the shift is happening slowly, but it is moving in the right direction. I see more and more enterprises wanting to do this. And especially at a global level also. First, India was seen as a place where you come and, come as a low-cost center or a talent pool, whatever might be the reason. But I think it is now shifting. No, you can do little cutting-edge work also out of here. And it is also attributed to more ecosystem growing here, newer startups doing cutting-edge work, going global, more VCs, international VCs coming in here. That also is changing the perception. So I would say it's combination of everything, and the word is reaching out in overseas offices of these companies, be it in US or Europe. So perception is changing, mindset is changing, and I can see that this is going to be on the rise. We just have to tap into the opportunity, probably create more confidence and more reach out to people, who are who do not get to see things here on day-to-day level. So a bunch of these things, I think if we do, I feel we are, it's not because we are in Bangalore, but I think we are sitting in a place where most amount of applications are being developed, most amount of use cases are being developed, we will have thousands of use cases, I think, as we go forward. And best place to tap into it is coming and doing this. That's a faster way of doing things. That's a That's a cheaper way of doing things, and you learn much faster along with the startup or the ecosystem.
Okay.
I just want to add here, to help explain the case. Um, the startups and enterprises is a symbiotic relation, right? It's like comparing elephants and horses, right? So startups are horses. They are fast. They are able to gallop. They're going to accelerate very fast. Enterprises are stable, organized, compliance driven, need a certain set of things to happen in an organized way. So they're more, say, wiser, for lack of a better word. So we do not want the startups to become elephants, become slow, start doing things what the enterprises are doing, follow process, go step 1, step 2, step 3. We want them to do things what they do best, crack things fast, right? And enterprises need to understand that you need to let horses be horses. So I think it's the job of the leadership to ensure that engineers work with startups in a non-competitive way. As Sanjeev rightly said, engineers can get competitive. You can do, so can I, right? So how do we make sure that they do their respective jobs, get the horses to gallop as fast as possible to a certain destination, and then the enterprises can come in and do the rest of the stuff, like shape it, do it, do the compliance part of it, bring it into an area where we can make sure it is taken care in terms of quality, compliance, and so on and so forth.
Wonderful.
Thank you, Uday. I couldn't have said it that nicely.
So, I mean, Kala, I'll just ask you to do your closing thoughts on this horses thingy. I mean, so your message to horses, in your particular, for this for all of four of you, in your particular areas, where would you advise, as your closing thoughts, what would you advise those horses to focus on in your area? And how do they, if they think they've done something really worthwhile, how do they get in touch with you and catch your attention that, listen, you could probably work with us?
Yeah, thank you very much. Very nicely said. Horses, they should go faster, right? They should create ideas faster, and they should come to us to scale for impact, right? So this is where it is extremely important for them to understand the whole landscape and clearly articulate where their value is. Okay, for instance, when it comes to healthcare, this transformation is very deep, okay, very personal for me. Every scan that is read faster, every diagnosis that is made much more accurate, every treatment which is more effective, and every surgery which is more precise. These are some of the human stories which will make us better from the heart, right? So I truly believe the future belongs to those who harness deep tech to move faster and, much more importantly, care better. So this is my path to success and making healthcare accessible. So I would ask the horses to be much more purpose-driven and get in touch, okay? Not give up, get in touch with the large enterprises to scale the impact.
Okay, be purpose-driven and get in touch. Rao?
I would say that, especially for us, sort of Indian startups, play a bigger role, understand what the what the world needs, and I would put on my priority productivity, safety, as well as efforts to unleash human potential. And that is where we are working on all these areas. Most of our solutions are able to offer to our customers all these things. So in case, and as rightly said by the other panelists, the startups can gallop, they can produce faster results. So why not partner with us for a very holistic, bigger role that we can all together play for the betterment of the world? I mean, energy, today we are in an energy trilemma. So we're making a lot of efforts to solve these problems. Why not join with us and try and find solutions for these difficult areas? There are a number of startups which have great ideas, and it would help a lot if we could, or they could work with us. And of course, we have to be open to them to take them along with us and solve the needs of the world, which is today sustainability, which is productivity, and through productivity, unleashing the human potential, as much as possible to do better value work, to do more creative work. I think we can do a lot of things if we work together.
Yeah, ABB willing to work with startups on productivity, safety, sustainability, anything that can augment human work. Yeah, Uday?
Yeah, I think startups need to take on complex problems to solve and solve them faster, right? So today we have a challenge that the startups here are a little bit more downstream, right? I would look at whether can they move a little bit more upstream, little bit more researchy areas, little bit more complex, topics where they can generate more, intellectual property, create more, value, differentiated value, more blue ocean, between red and blue ocean, topics, and take on these audacious, goals to solve them and bring it to a stage where the corporates can take it forward. It's where the energies must be spent, take on larger problems, complex problems, where their speed and nimbleness can help the corporates to generate more topics.
Take on more complex projects. Sanjeev, do they get the money to do all that? Closing thoughts from you.
So that's, as I said, that is changing now. It was not. Till now, that was the money was scarce when it came to topics or areas which were considered, when you're talking about innovation, research areas, they get more risky also. So our VCs were playing risk averse. 10-minute grocery was a better idea than working on a topic on quantum computing. Nobody knows, people are not sure of quantum, right?
When it will produce results.
So I think, but that is changing. Government is putting a new fund on research, and more VCs are turning onto the deep tech journey. So I have seen a shift happening in last 2 years, and we have to make a collective effort. How do we bring that mindset? But it is happening, and I would say changes are happening. Needle is turning, but we all have to make a collective effort around it. But I think when it comes to use cases, definitely this human augmentation type of use cases, those are going to be plenty. I can tell you that. Those will be, I think we will pretty much have a lead on that front here in India. But I think little groundbreaking technologies, what he's talking about, is something we need to do more.
Okay. Wonderful. Needle is turning. Things are definitely moving in the positive direction. There's plenty of scope for startups to work with larger enterprises. And we saw Kala, Uday, Rao, all of them saying that they are more than willing to work with startups who have those solutions that can augment human capabilities. Sanjeev, Rao, Uday, Kalavathi, really nice having you on this platform. I'm sure there'll be a lot more to discuss in the future. Hope to see you all again at some point. Thank you so much.
Thank you, Sujit.
Thank you.
Thank you, Gil. Thanks, everyone.
Bye.
Bye.
Bye-bye.